Hello everybody, Jones here. So I've been dabbling in network programming recently, and I want to showcase a project that I've been working on. I'll show it off first, and then we'll take a look under the hood. The libraries I'm using for this program are Winsock for the networking and Raylib for graphics and input. There isn't too much to show gameplay-wise because the game is still in its infancy, but I think it's got an involved enough networking backend that it should be of interest. So let's take a look. Here are my two programs, server.exe and client.exe. Now I actually have a remotely hosted server using Google Compute Engine, so I'm going to go to that and run server.exe. That's all it is, a console window. And now let's open up the client. So right now, let me close OBS. The client is not doing anything because we need a second client to initiate the game. So let's open it up. And now the game has started, which is a card battler. Right now, none of the mechanics are really implemented. All we can do is pick up cards, drop them on the field, bring them back to our hand, and that's about it. We can also shuffle our hand. And as you can see, the cards reorganize themselves automatically, making the game feel really smooth to use. So we can end our turn, and our opponent will move now. Also, on the other screen, if it's not your turn, you can also move the cards around. So that's all for the game. However, I've also implemented a lobby of sorts so that if you open up more instances of the game, let's say other people are trying to connect to the server, it will actually handle those games as well. As you can see, we can go back to our original game and continue playing as we were. And if we X out of a game, we can continue going. Okay. And that's all. So now that we've seen the end product, we can start taking a look at the code. So let's start with the server. As you can see, there's a client and a server project, which create the two different EXEs. So starting with server, we have three main parts: the network, the lobby, and the game. So the network translation unit is mainly handles the actual Winsock API call, so have some basic listening, receiving, and sending functions. Then there's the lobby, which handles some of the more specific kinds of things we want to do with our networking. So for example, we can add a client to our server, we can handle any disconnections, and we can also create games when we have enough clients. And then the game translation unit is basically handles the actual game state, which is mainly held in this player struct here. Going over to the client side now, there are a couple more extra parts. We still have network, which is basically the same use case. We have game, which is since the game logic is actually running on the client side, it's a bit more involved. We have entity, which is going to hold our card objects and the player objects, which are basically containers for the cards. And we also have graphics. I'll go into a little bit more why this one's needed. And of course we have utilities, which is where we hold our packet type, our packet struct, which is the data that's going to be sent across the network, and the state of our cards. So before we go deeper into the code, I just wanted to mention something about the technology I'm using, namely Raylib and Winsock. So there are conflicts between the two, and that's because Winsock includes the Windows header files, which Raylib actually collides with. And that's because they're naming collisions. Since Raylib is very simple and has very simple naming conventions, it collided with some of the Windows API calls, like this close window function. To solve that, you just have to make sure that Winsock and Raylib are not included in the same header files. HPP, I have to make sure only one of them has one of the header files. Otherwise, if I try to put Raylib in graphics.hpp and I try to build, you'll see that it failed because of all these naming collisions, like with rectangle and draw text. So just something to know if you plan on trying out Winsock and Raylib together. Okay, so now it's time to dive into the code. As you can see, I added some comments so that I can organize my thoughts here. So first we initialize the network. That just means calling some functions from Winsock in order to set up the sockets and everything so that we can get the server communicating with potential clients. Then, in a while true loop, we first listen for any connections. So we're listening to see if any clients have tried to connect with us. And if that's true, then we can accept them. And as long as it didn't fail, we can add them to our list of clients to the server. Then for each client that we have in the server, we're also going to listen on each of those clients. So each of these clients has their own socket associated with them. And on their sockets, we're going to be listening for any packets being received. And when they're received, we're going to add it to a queue so that we're going to process later, right down here. So now, as long as there's packets in our receiving queue, we're going to pop them off and handle them one by one. So if we're going to handle any disconnections, if there's a disconnect, we're going to, so this update function, kind of poorly named, all it does is it checks if new games can be created with unconnected clients. So we can see that here. This just checks if there's any two clients that aren't connected to a game yet, we create the game. And then next we're going to update the game state based on the packets. And we're only going to do that if the packet is from one of the players. If it's not, meaning it's from a different game instance, then we're not going to handle the packet. And we're also going to make sure that the packet is from a state where we're in the game. I'm not sure if I still need this check, but let me just leave it in for right now. And in this last part, we're going to send any messages that are queued to their respective games. Okay, and so for this last part, we have we're going to handle any messages that need to be sent to the clients on our connected to the game. So for each game, we're going to iterate through the sending, well, queue or backlog. It's not really a queue. And if the packet is meant for the players of the game, we're going to send it to those players. And so the clients on the other end will be updated after that. Okay, now the implementation of these functions isn't necessary right now. Now the implementation of these functions I don't want to go into right now, as that would basically be me describing the whole Winsock library. As you can see, these functions kind of call their respective Winsock functions. Like this one's a specific socket function, so is select. On the receive end, we have receive. And on send, we have the send function. So these are Winsock functions that are based on the sockets that Linux uses, or Unix. So for the lobby, one interesting part is the create game function here. One of the things I do is I try to create a unique game ID. It's not really unique because it's just random and there's no checks or anything like that. It just basically gives a random 32-bit integer using the bit shift operator. So theoretically, I think it should have a probability of 1 in 2 to the 32 power or something like that. And now the one part I will go over is the game.cpp file, which controls the game state sort of. So first, when we create a game, it's just going to be created in its constructor, and then we're going to set up the players. And this setting up the players is basically what holds the state for now. Because the players have a vector of card states, and the state of the cards is basically all the state of the game. This code updates the state based on what packet is being received, and when we want to send out the state of the player in the game, then we run this routine. So that's all for the server. Let's take a look at how the client functions. Now the client's going to get a little more involved than the server was because there's more game logic going on, but let's take a look. First off, just like with the server, we initialize Winsock to get our networking up and going. Then we're going to initialize Raylib. So first we start off by trying to connect to the server, and we only run this code every second or so because we're pinging the server or trying to connect every second. That's what this little small tick struct is right here. So and this only happens if the connection state is none. If we're not connected, we try to connect. And also, if we did connect and we're in the lobby, that's when we start pinging the server to tell the server that we are here and we're trying to get into the game. So this might be a little confusing, but this is basically checking to make sure that our connect function worked and that we actually can connect now. So that's what this network listen function does. It makes sure that we did actually connect, and if we were connected and in the none state, then we go into the lobby state. Over here, we're listening for any packets, and then we're receiving the packets. Next, we're going to pop whatever packet is on the queue, and we're going to process that packet depending on our state. And after that, we're just going to, these are where we call the draw routines that are mainly graphics calls. So if we want to go down here, pinging the server, that just sends state to the server, as you can see here. And then once the data is sent to the server, it can receive it and then send the data back to us. So that's how the server and client communicate with each other. It only sends the data when it receives data, and the client only sends data every so often when a change happens. Okay, so in this wait for game function, this is the process of what we do when we're waiting for a game. First of all, we don't process the packet. If the packet is not ready for connecting to a game, then we're not going to process it. Then, as sort of convenience, we check if the packet that we're receiving was sent from our own client. So if the packet ID is equal to the session ID, and that session ID, which is kind of like the game ID right here, where it's generated as a 64-bit integer this time. That's going to mean that we're the host. If we're not the host, then the game peer, the opponent, is going to get that ID. And then we're going to populate the cards. So we're going to fill the cards of each player. And this is not card state. So when we looked at the player struct in the server side, we had a vector of card states. That's different from the actual card objects. We're going to take a look at the card objects later, but as you can see, it's a lot more populated than just the state. So we create those cards and then put them into the player, whether that's the host or the peer. Now, if we process both the host and the peer, then that means we have data for both players and we can start the game. But if we didn't process both the packet being sent from the player and the opponent, then we won't start the game yet, and then we'll come back through here. And for run game, this one's pretty straightforward. All the logic is encapsulated behind these function calls. We're going to update the game logic. Then if we're supposed to send a message, so if we queue a message, meaning something changed in the game that has to be communicated to the other client, then we send the state. And then we also send the server state back to this client at the end here. So here we're sending the client state to the server, and then we're updating the client state with whatever the server authoritatively says. Once again, we don't really have to look through the implementation on this side. I will note that when the network is deinitialized, meaning we close the window, it does send out one more piece of data with the state at disconnected to let them know that we've disconnected. So now we're going to get into the actual game logic. So the first main function that we have that's going to handle some of the logic is this handle input. So the only input we have is pressing the mouse button and dragging it around. So one of the first things we want to do is highlight whatever card is being hovered at the moment. Now when we press the button, the left mouse button, That's when we select a card. And also this is targeting flag right here is what determines whether the card is being automatically placed, that smooth easing. And when the mouse button is held, then we're going to set the position of wherever it is. And if we're playing, if we're in the play state, so it's our turn, then we're going to change the place of the card depending on where it is. And then if it's the opponent's turn, this just limits where you can drag the card. So if it's in your hand, then you can't lift it out of your hand, and if it's on the field, you can't bring it back to your hand. And then if we release the mouse button, if it's on the end turn button, then we end the turn. Otherwise, we just deselect the card. And when we deselect the card, that should also order the cards. And because we're doing something new, that should queue a message to the server. So this was our begin function. All we do is draw 5 cards for each player, and we move the windows as a convenience. Start turn. These are kind of unnecessary, the phases right now. They're just in there for future purposes in case I need them. But the thing is we draw 1 card. This just ends the turn, and when the turn ends, we queue a message. The function for drawing a card, it sets the top amount cards in your deck to the hand place, and then reorders the cards. And this is our big update function, which calls a lot of the other functions we looked at. So we have start turn if the phases start, we handle the input, and then we order the cards. So let's take a look at that function first. All right, so now order cards is basically just a container for the other order functions for the hand and the field. So the order function is where a lot of the magic happens. So here we create a container of pointers to the cards, and then we fill that container depending on what place we have. So we create a function pointer that we're going to pass to the std sort method. And this is important why we have to order the cards every time we move the mouse as we're holding. And that's because we order the cards by how far their X position is. If we're talking about the opponent's card, the cards at the top of the screen, those are sorted by index because they don't move aside from when we target them. Okay, and then we pass that sorter into the sort function. And what we're doing here is we're basically queuing a message if the current index of the card does not match where it is in the container now. And then this right here is what sets the target of our cards to a certain position, so that they move and ease into their positions. Speaking of which, let's take a look at the card now. This is the constructor for the card that's actually used. These actually aren't used. This just sets up the state for the card and its position. These have to do with the positioning. These are state altering cards, so they modify the state, and that state is what's being sent in the packets. Okay, so the update, this is where the tweening and easing happens. So if the card is targeting, we have this t variable, which is basically just an interpolation value. And we're going to just use an interpolation function to tween the x and y values from their starting position to the target position. The particular easing function we're using is a quintic ease out, I believe. Either ease in or ease out. I'm pretty sure it's ease out. It goes fast and then slow. All we do is we set the position to whatever that tweening value is. If the t value is to 1 or more when multiplied by speed, we set the position to that spot, and then we get rid of the targeting. So it's no longer targeting. It's set at its position. And with that, I think we've gone over all the code we really need to do. Before I close out this video, I just wanted to share the 2 main resources I used to learn about network programming and write the code for this project. So the first I have right here, Beach's Guide to Network Programming. This is basically the go-to beginner guide to socket programming, and you'll see it linked on plenty of Stack Overflow questions. If we look inside, we can see it starts with some conceptual information about the technologies involved, and then it'll show plenty of code examples as well as explanations of the API calls to get started. For a more thorough or hands-on approach, and specifically if you're programming on Windows, the Winsock 2 documentation has a very good getting started guide for building a simple TCP client and server. That would be right here. Personally, the way I did it is I had read through some of the Beej's guide before going into the programming myself. Then I went through the whole getting started tutorial on the Winsock documentation with that context. And after that, I went back to Beej's guide to finish up with the context of now being able to program with it. And also for looking for any specific details I needed, like on blocking or the select function. So those are the recommendations I can give to someone who, like me, who's just starting out with network programming. I want to reiterate that I'm just a novice at this stuff, so there are probably some mistakes I made in my own implementation. So for example, I didn't convert the packet data to network byte order before sending and receiving. So there would probably be some endianness issues on certain machines. So I invite anyone with a working knowledge in networking to correct or give suggestions to improvements in the code base. Also, I am interested in doing an in-depth tutorial or series of tutorials on the networking aspects of the program. That would cover material not always reached in a lot of the content that's out there already, such as having a server that can connect and handle multiple clients, calling socket functions without blocking the program, and passing data that isn't just text. So if you'd be interested in that sort of thing, feel free to let me know via the comments. Maybe give a like and subscribe to stay updated on what I plan to do. And until next time, keep coding.